All right, we are going to be factoring completely. You've already been factoring, and we actually started doing some of this already when you were doing your division with rational numbers, and so it shouldn't be too bad. So let's do a problem, all right? You look at this problem, and the first thing you're going to do is factor out the greatest common factor, and look to see if you can.
So 3, that's all you can.
There's a letter you can take out of both also.
Oh, this is 1. I'm sorry, you can take out the y.
Yes, a 3 and a y. If I take out a 3 and a y, that means I'm dividing it out. When I say take it out, if I take a 3 divided by 3, it's gone. The x squared is the only thing left. Okay?
And then minus 4.
Yes. And another way to look at it is, what 3y times what gives you that? It's x squared, and then 3y times what gives you 12y, and it's 4. Now, when they say factor completely, now we have to look to see what we had left. Can it be factored now?
X minus 2 and x plus 2.
Yes. And so we bring down what we've already done, the 3y, and this thing can be factored again into x minus 2 and x plus 2. This is the factor completely.
Oh, okay.
You've already been doing this.
I was going to say I've already been doing
when
that.
you've been doing this on, especially when you've been doing your canceling your rational expressions. Okay, so let's do another one. What can I take out of all 3 of those?
A 3.
A 3? Maybe? Yep, 3. What about any letters? Can you take any letters?
You can take out an x.
Yes.
So
3x times what gives me 12x to the third?
So 4x squared.
Okay.
And then you're going to have 12x.
Yes, 12 and x.
And then 9.
9. Now, we've done that part. Can this be factored? Okay.
Yes.
And I like to do the box. You still do the box, right?
Mm-hmm.
Okay. So what can be taken out of 4x squared?
A 2x.
Okay. 2x and another x, right?
Yes.
Okay.
And then you can do a 3 and a 3.
Okay, so let's see. If we do a 3 and a 3, are they both negative? They're both positive? One.
Oh, yeah. I got ahead of myself. A negative.
Which one's is one?
It doesn't matter.
Okay. So if we do that, that's going to be a negative 6x, and this is going to be a positive 6x, so that won't work.
No. So we're going to have to do 9 and 1.
Okay, so you want a negative 9 and a negative 1, or you want
No, a negative... Oh, yeah, I guess I do have to kind of think about that. A negative 1.
A negative 1 and a 9. So this is going to be 18.
That's not going to work.
And that's going to be a 2.
Negative.
So then...
So that's not going to work either.
Okay, so 9 and 1... So
you could do 4 and 1.
Okay, so we're going to do 4 and 1, 4x and x. And then do you want, for your 9, you want to do 9 and 1, or you want to do 3 and 3?
3 and 3.
3 and 3? Which one do you want to be negative?
Actually, no, I want 9 and 1.
You want 9 and 1, okay. So do you want the 9 down below or the 1 below?
The 1 below.
The 1 below. So you want 1 down here, and you want the 9 up there.
Maybe.
Which one do you want negative?
Hold on. If I do...
Oh, you know what? How did this become negative right there?
I don't know.
I don't either. It should be plus. So then, that helps everything.
Yeah.
It helps everything. It helps everything because...
I was like, because this isn't going to work
This isn't going to work either way. Okay, so then this is going to be...
So now we can do...
Yes.
Our 2 and 2 and 3 and 3.
Yes, and they're both positive. So this
Right.
is going to be 6x. That's going to be 6x. For a total of 12x. All right, so we have 3x here.
And then 6x, or 2x plus 3, 2x plus 3.
How can I write this more simplified?
You can do 4x plus 9.
You cannot, because when you multiply it out, it becomes this.
Wait.
But I have this, 2 of those.
So you can do 4x, no. 2x plus 3 and then squared.
Very good.
That's what I was going for, kind of.
Very good. All right, here we go. Let's do this again. Now, this is a new one, okay? You've never seen one like this before. But a minute ago, we had a second-degree trinomial where we had 4x squared plus 12x plus 9. Is that correct?
Mm-hmm.
Okay, I want you to notice this is a trinomial, okay? And It's a second degree, meaning that's the highest degree, okay? And this one becomes half on the next one over.
Right.
That's how this one is, although it's a trinomial, but it's not a second degree trinomial. But it's in the form like this. This is called a quadratic, and you'll learn that term later. This is in the same form. We have a fourth degree, and half is right there.
Okay.
So we can factor it very similarly. Okay.
So just x squared and x.
Yes. So we're going to do this. And we're going to do our box.
Okay, so then we can do x squared and 9 and 9, but they both need to be negative.
Okay. So we're going to have...
So x squared minus 9, x squared minus 9.
Now, we're not done.
Wait, what about the squared?
Thank you.
Oh, okay.
Yeah, keep me in line. Keep me in line.
I thought I had messed up.
No, you didn't.
Like,
you didn't.
I don't know what I'm talking about.
We got to get, we're going to move some, because we are not done. We're not done because I want you to look at that x squared minus 9. This x squared minus 9 can be factored.
It can, to x minus 3, x minus 3.
Be careful. Not x minus and minus. X minus 3 and x.
X plus 3.
Yes. And this one can also be factored. This one can be factored.
To x minus 3 and x plus 3.
That was a terrible handwriting. Let's do this one again, because that looks like some strange thing. Okay, now I've got these are the same.
So now you can
We can't cancel them because they're not top or bottom, but we can
do x minus 3 squared.
Very good.
X plus 3 squared. Oh my word.
Woo! If you multiply all this out, it will become
that.
Okay.
Why you would ever want to do that, I don't know, but
there we go. And that's actually quite cool how that big thing kind of multiplies down to that.
Yeah.
I think that's pretty. All right. Now we have this one. This is like what we call a difference of squares, like we had back here. It's just not to the second power, it's to the 16th power. So if I came in here, I could do x.
4.
Is it fourth?
Mm-hmm.
Mm-hmm. And x to the fourth, right?
Mm-hmm.
Minus 1 and then plus 1.
Mm-hmm.
Both of these, one of these two can be factored again.
Uh-huh.
Which one can?
This one.
Yes, and this one has to stay as it is because it's a plus.
Mm-hmm.
Okay? So then I can come in here, and I'm going to write this x to the fourth plus 1 as is. And what does this one become?
X squared minus 1. X squared plus 1.
One of these can be factored down
This
again.
one.
And yes, this one here can, but the rest cannot. So I'm going to rewrite x squared plus 1 and x to the fourth plus 1. But this one
Can be x minus 1, x plus 1.
Man, oh man. Look at that. That is the completely factored form of that.
Okay.
Okay, and we are finished. We have factored completely. We've done quite a few examples of different ways to factor. You just have to keep looking for
Things you can factor.
things you can factor. Remember that you cannot factor a sum of two squares, but a difference of two squares you can factor.
Okay.
Okay? All right, we're done.